Following up on the previous exercise, let's suppose we have the same program, but now one more restriction. The final sum should be smaller than or equals to 165. How would this change the way I did the analysis? So let's just see. First, I would do the same variables, types, and ranges analysis, so x and y. I would also analyze the output, still the same, right? Integers in between this interval. But now I know that the result of the sum, it has to be something between between 0 and 165. Dependency among variables. I see that x and y are still independent, so one does not really affect the range of the other. X and y are still used to calculate the sum, but I have this extra restriction. Great, then we move to the equivalence partitioning, and I would still do x and y separately. So the same way as we did before. We found 7 classes for x, 7 classes for y, but now I would just do one more, and I am gonna combine both variables. For me to test that restriction, I need to see x and y together, and that's why I put there x and y together. I know that, well, the limits, I have to follow this rule, x plus y is smaller than or equals to 165. I know that an invalid class is the other way around, so if x plus y is greater than 165, that is invalid. And I also have boundaries, right? So the 165 is the on point, the 166 is just the off point. So I just have more tests, yeah? So I still have 7 for x, 7 for y, and I saw 4 for this combination. But given that, you know, this one over here and this one over there, I have already tested kind of together with my tests for x and y. I can ignore those two and only focus on the boundary there. And that's what I'm gonna do. So that's gonna be my strategy. The 14 tests we had plus 2 extra tests for this new restriction that appeared. When it comes to generated tests, there's just one more thing that I need to pay attention, because when I was testing x, I was choosing in points for y and vice versa, and that was easy. But now when choosing these in points, I just have to take the new restriction into consideration. So I have to pick an in point for x that, you know, makes this valid. X is smaller than or equals to 165 minus y. So in other words, I need to pick an x and a y that works, right? Otherwise, if I choose one that doesn't really fit into this constraint, I'm gonna have behavior that I don't want in my test. So that's the only thing that I need to be careful. And if I go to the tests, I have the 14 tests that I had before, didn't change, and then 2 tests for the boundaries. So the first one, where the boundary is precisely 165, I chose 2 numbers that are in the mid-range, right? So 82 for x, 83 for y, it could be vice versa. I'm not really sure if I need to choose more numbers. I don't think so. I cannot see a reason why I would test, you know, forcing more towards the x side or more from the y side. I don't really see a reason for that. And then I test the off point. 83 seems to me like the real moment where the boundary changes, and the program returns invalid. That should be the output. So that's it. That's how I took this extra restriction into consideration in this problem.